everyone. This is James. Welcome to Lab01 Charged Tapes. And the purpose for this lab is to approximate the excess charge on one piece of tape by observing the interactions of two charged pieces of tape. And here are some fundamental principles involved. And this includes the density formula for calculating the mass of the tape, also the gravitational force on Earth, which has been covered in Physics 1, and also some new ones, including the Coulomb's law to calculate the force of a point charge and an electric field, which you just have to divide it, the force by the test charge, and you'll get it. And that's also given by the first equation. So starting with the experiment, the length of each piece of tape is measured to be 20 centimeters in length, and the mass of the tape can be calculated by the density equation, which is given by m equals to rho v. And however, in this case, we were given that the clear tape is around 1 gram per meter. So what we have to do is just to multiply the length of the tape by this 1 gram per meter to get the mass of the tape in grams, which is 0.2 grams. And the distance between the two tapes when one begins to float above the other is 2.22 centimeters measured by the ruler. And the reason why one begins to float above the other is that both of the tapes are charged with the same sign, and they're both positive, so they repel each other. When the bottom tape reaches a close distance to the top tape, they will repel each other, and the tape above is going to overcome gravity and starts floating. And the magnitude of the gravitational force is given by negative mg, which has been covered before. And by plugging in the values, including the mass of the tape, you can get that it is equal to minus 0.001962 newtons in the negative y direction. And since we know that because it overcomes the gravitational force, the tape is floating, so that the electric force caused by the tape below should be equivalent in magnitude, but in opposite direction to the gravitational force exerted on the tape. So we know that this force should be 0.001962 newtons as well, but in the positive y direction. This is the row script code. The initial conditions includes all the constants that we've been covered in this slide. And another one included is the length of an atom, which is 1 times 10 to the minus 10 meters. And the width of the tape is neglected because as long as we know the length, we know the mass for the tape. And what was the magnitude of the charge on one piece of tape as calculated by my computational model? So we know that the electrostatic force caused by the tape below is equivalent to the gravitational force, but just in opposite direction. We can use this equation to calculate the charge that is on each of the tape, which caused this electrostatic force. And by this calculation, we can come to a conclusion that the charge on one piece of tape is 1.036 times 10 to the minus 8 coulombs using the equations on the right side. And this is my glow script model display. And it can be seen that the force, which is the magnitude of the red, on the red ball, that includes the sine arrow and the orange arrow, are equivalent in length. And here are some assumptions made in the experiment. So I treated the long tape as though it were a point charge, as shown in the model, and with all the charge concentrated in the center of the long tape. And I used this for my calculations, so everything can be simplified. However, this is a simplification. And I also assumed that each U tape, which is the upper tape I made, had about the same amount of charge evenly distributed along the length of the tape, which is being covered in the entire experiment. If it's not evenly distributed, the charge may vary because the concentration of the charge varies. The what if question asks, if electrons had a positive charge and protons had a negative charge, the charge is reversed, what would change about the observations I made with my tapes and other charged objects? So first of all, the two tapes are both becoming negatively charged because they have lost electrons and protons are negative. However, their interactions will remain the same because they will still repel each other. The electrostatic rule of having similar signs to repel each other and opposite signs to attract each other will not change. And the second question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with my hands or other objects? So the interactions between neutral or charged objects with the charged tapes will cause the charged tape to dissipate electrostatic energy by gaining or releasing electrons through conduction, depending on the other object. Much of appreciation.